This is a session put on by the Chainalysis training team. So as just mentioned, my name's Adam Hart, and I've got my colleague Joe up here with me. We're both trainers. We talk at people all day. So if you've been subjected to us on a training course before, apologies. Thanks for signing up for more. And we'll swap mics. We can go no mic, but yeah.
Not for recording, we can't.
Yeah. All good now?
Yes.
Cool. Okay. So welcome to this training session. Today we'll be covering the Lightning Network and a little bit on how we can do transaction monitoring on the Lightning Network. So we'll begin with background on why the Lightning Network exists in the first place. You've likely heard of it before. We'll get a little bit into how it works. We'll try and stay out of the technical nitty-gritty, but more than happy to discuss some of those details if you all have questions at the end. Then we'll talk a little bit, very briefly, about how the Lightning Network's being adopted, what we're seeing in the data, what we can see in the data, and what maybe we can't see in the data. And then lastly, we'll talk about how businesses, as we've seen more and more major centralized exchanges and other entities adopting the Lightning Network, how those entities can conduct transaction monitoring, what's possible, what data is visible, and what data is not there, how it might compare to traditional Bitcoin transaction monitoring. But let's begin with the Lightning Network itself. Why does it exist? Well, it exists because of the way Bitcoin is designed. Bitcoin is designed, or it was envisioned, as a peer-to-peer payments network without where I could send money over the internet to anyone in the world without trusting a centralized intermediary. And to do so, to accomplish this, Bitcoin has to be a decentralized network. It has many node operators, it has many miners spread across the world. No one entity is in control of the Bitcoin network. However, in order to achieve this decentralization, the Bitcoin network was designed in certain ways, and those certain ways have an effect on how effective it is as a payments network. So Bitcoin is sort of our base layer. It's what we have right now. It's what most folks in this room are probably familiar with, but it does have some limitations as well. And the big limitation that we'll be focused on, especially in the context of the Lightning Network, is the usefulness of Bitcoin as a payments network. So if Bitcoin is intended to be a digital form of cash, presumably it has to be quick, easy, and cheap to send money over the Bitcoin protocol to someone on the other side. And in order to do so in a peer-to-peer manner, I need to do so without, going through a centralized exchange, going through an equivalent to a Venmo or some other centralized service there. And right now, it's possible to do so on Bitcoin, but it might be expensive and it might take a little bit of time. Why is that the case? Well, we could have a whole 30-minute discussion on, why that's necessary, how that feeds into sort of the design of the Bitcoin blockchain. But essentially, the stat that matters for us maybe more as users here is on the Bitcoin blockchain, we can only cram about 5 to 7 transactions in per second on average on the Bitcoin blockchain. Now that compares in comparison to a network like Visa, a fully centralized card payment network, where we can process thousands and thousands of transactions per second. Now, there are certainly things we could do to improve the efficiency of the Bitcoin protocol to cram more transactions into, say, a given block. But as a payments network, if Bitcoin is truly going to be peer-to-peer digital cash, processing payments for lots and lots of users all around the world, it probably needs to be able to process more transactions at a time. And that's where the Lightning Network can be really useful. Because again, the Bitcoin base layer, Bitcoin, the protocol that's widely used, widely known, it's limited by design. Roughly, we can only have 1 megabyte of data in a block. And we're oversimplifying a little bit. We won't get into things like weight units. But roughly, we've got 1 megabyte of space to work with. And that 1 megabyte of space comes every 10 minutes. That's our limitation here. That's our limiting factor. And that's a deliberate design decision for the Bitcoin network. It's designed to keep the Bitcoin network decentralized. There have been all sorts of disputes and debates over the history of Bitcoin, but essentially that 1 megabyte, 10-minute block time is designed to keep the Bitcoin network as open, as decentralized as possible. However, there are certain things we can do to improve it. Maybe we can make those blocks more efficient. Maybe, again, we can tweak the way those blocks functions. But that process of improving Bitcoin is slow and time-consuming and, frankly, very difficult to do. And that's, again, by design. Bitcoin's a decentralized network. There's no centralized entity that can simply issue a patch and update the way that the Bitcoin network works. Therefore, in order to try new ideas, to experiment maybe a little bit more rapidly and build things on top of the Bitcoin network, we have to turn to solutions off the main blockchain. To capture that payments use case, to really conduct peer-to-peer payments, maybe we want to go to a network built on top of that decentralized base layer.
And actually, before you leave that slide, something to just kind of have in the back of your mind is the contrast with Bitcoin Cash, right? So Bitcoin Cash, results of a hard fork in the Bitcoin blockchain where people and participants in the network could not reach consensus about modification to the Bitcoin blockchain, specifically expanding the size of blocks to 8 megabytes in the name of incorporating more transactions into each block, and so making it a more transactionally viable cryptocurrency. But the problem with expanding blocks to 8 megabytes is that it would make the blockchain much, much larger and therefore more expensive to store. You need more hardware in order to participate in the network. So there's this kind of idea of transactionally viable, but with an inverse relationship to decentralization. So we want to keep the elements of decentralization that we have with the Bitcoin network and not force participants out because they're trying to store too many transactions.
Exactly. Yeah. Thanks so much, Joe, for that. And the way the Lightning Network sort of tries to address this is by using that decentralized network that is Bitcoin as the base layer, as sort of an arbitration system. And the Lightning Network is built on top of that decentralized layer. Essentially, rather than publishing all transactions on the Bitcoin blockchain, which is where we have that limited space, that limited block availability, instead the Lightning Network tries to take a lot of those payments, move them off-chain, and then use Bitcoin as sort of the trust layer. As an arbitration system, if there are disputes, the users of the Lightning Network can fall back on that decentralized network to sort of resolve those disputes. And that's really the design of Lightning Network as a layer 2 solution, and lots of other layer 2 solutions that exist on other blockchains. Today, we'll just be talking about Lightning, how it exists in relation to Bitcoin, but this concept of having a decentralized base layer that's sort of an arbitration layer, and then change other layers of maybe more payments-focused networks built on top, that's a concept that is used on other blockchains like Ethereum. It's a common scaling solution. But specifically, how does the Lightning Network work? How does it function as a payments rail? Well, we like to think of it kind of similar to a bar tab or a Venmo balance. If I open what's called a Lightning channel, a path for me to make payments repeatedly, maybe I go to Bob's coffee shop all the time, and I know that it would be expensive for me to pay the transaction fees and it would be slow to process every single time I buy a coffee on the Bitcoin blockchain. If I can go and open a payments channel, and maybe I fund it with $500 worth of Bitcoin, every time I buy a coffee, I can send a little bit of money over to Bob's coffee shop, and we update, essentially, my tab with Bob's coffee shop. We can change the balance each time I make those little payments, and that's the rough concept of a Lightning Network channel. It's kind of like a bar tab. We make little adjustments as we go. Now, what can we see on the blockchain? What actually shows on the Bitcoin blockchain itself? Well, when I open that channel, when I open my bar tab, we have to make a transaction on the base layer. We sort of have to tell the Bitcoin blockchain that, okay, we're setting up this second layer solution. And when I close it, when I settle my bar tab, we have to tell the Bitcoin blockchain again, because that's the sort of dispute resolution layer. We have to tell it when it opens, we have to tell when we close, and that's what's recorded on the blockchain. What happens off-chain, what happens on this second layer solution, are all those little payments in between. Every update to my bar tab, every time I buy a coffee, that's the update that occurs off-chain, where I don't have to worry about paying transaction fees, and I don't worry about having to cram my information into that limited 1 megabyte of space on the Bitcoin blockchain. So this is a scalability solution. Commonly, we refer to this idea of having these sort of bar tabs happen off-chain as state channels. And that idea of a channel, that idea of a tab between two entities, that's something that you're going to see come up again and again through this training here. That's sort of the core concept of the Lightning Network. We have payment channels. What are these channels? How can we understand them? Well, payments within a channel, kind of similar to a bar tab, are private to the parties involved in those transactions. They're not broadcast to the entire network. And this is a big difference between a state channel like Lightning and a public blockchain network like Bitcoin. On Bitcoin, when I make a transaction, I broadcast it to everyone. Everyone on the Bitcoin network knows that money moved from account A to account B. They might not know that it's a payment from Adam to Bob's coffee shop, but they know that a transaction occurred. On the Lightning Network, that is just local to my tab with Bob's coffee shop. It's not broadcast to the network. It is simply an adjustment to my bar tab with Bob's coffee shop, and not everyone knows about it. They only know about these state channels when they are opened and when they're closed, or more specifically, we get more details actually when they're closed on the Bitcoin blockchain, and we're glossing over a little bit of technicality there, but essentially those are the two times, and the only two times, where information is put back to that public blockchain where everyone can see that a transaction has occurred. So roughly, Lightning Network is designed to be payments. It's designed to float on top of Bitcoin, where Bitcoin can be expensive in terms of fees. We've seen in times of high demand, where there's a lot of demand for that limited block size on the Bitcoin network, fees can skyrocket, pricing out users who want to, say, buy a cup of coffee. And additionally, as we briefly mentioned, the Bitcoin blockchain, blocks arrive every 10 minutes. If I want to have my funds clear, I'm going to have to wait, on average, a minimum of 10 minutes. Probably, I'm going to have to wait a little bit longer. That's just not feasible for the type of payments that maybe you want to do with a decentralized internet money, and that's where the Lightning Network is designed to help. That's where it's designed to be cheaper, it's designed to be faster, and it's designed to not broadcast your transaction to the entire network. Maybe you don't want everyone to know about your payments with Bob's coffee shop. That is a transaction that's local to you. So that's the goal. But how does the Lightning Network actually work? How does it go about achieving those goals? And does it achieve those goals perfectly? Well, as with all solutions, the answer is it makes some trade-offs, right? And inevitably, in order to achieve this functionality, we have to sacrifice some other things. So let's start to unpick what's happening under the hood of the Lightning Network, and where maybe there are some pain points in the user experience. So what's the life cycle here? Well, again, we've got these three key steps that we like to think about, especially from an analytical perspective, because this is really what we can see and what we can't see. Step one is I open a channel with another party. And again, here we'll talk about a direct channel for now, but I want to buy my coffee at Bob's coffee shop, and I'm going to open a channel with Bob's coffee shop. Here, essentially, Bob and I, we agree to open a channel. We both sign some commitments and open that channel on the blockchain. Maybe I fund it with 1 Bitcoin. I think I'm going to spend a whole lot of money at Bob's coffee shop. Yeah, Bob charges expensive prices for coffee.
It's a perfect opportunity to use an actual bar as a metaphor, so I can't believe you keep going back to Bob's coffee.
I'm in a coffee mood, Joe.
Oh my gosh.
You got to stay caffeinated today.
I establish a financial relationship with the bar. I don't want Bridget to know how many drinks I had, and then I close it. There it is.
Fair enough. But if some of us are not interested in drinking at 1 in the afternoon, we might go to a coffee shop. So we have a channel with Bob's coffee shop, and I can make lots of payments in that channel. I can spend my 1 Bitcoin balance with Bob's coffee shop, and each time money flows, we make an update. We update the tab, and it doesn't have to be one directional either. Maybe Bob's coffee shop, maybe they have a giveaway program, and after I buy 10 coffees, I need to stay highly caffeinated here, Joe, and maybe after the 10th one, they refund me some money, and they can send that back over the payments channel. It's a bi-directional payments channel. We can just update the balance of, okay, now Adam has $10 worth of Bitcoin more, and Bob's coffee has $10 worth of Bitcoin less. So that happens. That's where the majority of activity happens on the Lightning Network, within those payment channels, with those private transactions not broadcast on any sort of public blockchain. When the channel closes, let's say I want to close out my tab at the coffee shop, what do we do? Well, there's 2 ways of going about it. The easy way, and the way that the network is designed to function, the way that it should function if both parties are acting in good faith, is that we close the channel together. We both agree on the final state of the bar tab. Maybe I've spent a total of half a Bitcoin at Bob's coffee shop. Now each party would say the final balance here is Adam has half a Bitcoin, Bob's coffee shop has half a Bitcoin, and we agree to close the channel, basically signing out, closing that bar tab. However, sometimes, maybe Bob's coffee shop is not available. Maybe I want to pull my money out, or maybe Bob's coffee shop is trying to scam me out of a little bit of money. Maybe they publish a claim saying, actually, I have Bob's Coffee Shop has 0.6 Bitcoin, Adam's only got 0.4 Bitcoin. If we didn't actually sign those transactions or more or less commit to that state of the bar tab, if those weren't legitimate updates to the bar tab, I have the option to go back to the Bitcoin network and use the Bitcoin network as a dispute resolution mechanism. I can, using some nifty cryptography and using some nifty network design, I can go back to the blockchain and prove that the true state of the tab was 0.5 Bitcoin for Adam, 0.5 Bitcoin for Bob, and use that decentralized network of Bitcoin as my dispute resolution network. The decentralized network that is Bitcoin, no one can control it, no one can manipulate it. If I can prove, according to the network rules, that I was owed 0.5 Bitcoin, I can close out that tab successfully. And actually, the way the network is designed is I can take all the money because Bob's Coffee Shop, they tried to cheat the system, therefore they're going to be punished. So again, that's where things get a little bit more complicated, and we won't go into sort of the cryptography behind that or some of the design decisions there, but we have a life cycle of a payment channel. Where do things get more complicated? Where do things get more tangible as a user here? Well, if I want to actually go and open a channel with Bob's Coffee Shop, I need a way of interacting with the Lightning Network. I need a wallet. And it turns out a Lightning wallet needs to be able to talk to both the Bitcoin blockchain, that dispute resolution mechanism, and to the Lightning Network itself. So my wallet needs to be connected to a Bitcoin node and a Lightning node. And that's where things might get a little bit complicated for me as a user. Because in order to send or receive payments on the Lightning Network, I need to be online. My node needs to be able to communicate. We're passing messages back and forth about the state of my bar tab. Therefore, my wallet needs to be online. And that's a risk. I now have a hot wallet. And that's a potential pain point in the user experience. However, in comparison to Bitcoin, Lightning is designed around payments, right? So probably I don't need to store a massive quantity of Bitcoin in a Lightning wallet. Nonetheless, it is still a potential user experience pain point to have my wallet online pretty much all the time. And it really does matter. Having your Lightning node online all the time and constantly available, not being shut down, that matters because if you go offline for more than a set period of time, it depends exactly on how the payment channel is constructed, but maybe if you're offline for 2 days, your counterparty, they might be able to steal your funds. You have to be online in order to use the Bitcoin blockchain as the dispute resolution mechanism. You have to be online monitoring to check if your counterparty in your channel is trying to cheat you. And if I opened a channel with Joe, I'd want to be very online. I don't really trust Joe with my money there. But keep your coffee. Thanks, Joe. How do we actually open the channel? What does that look like? Well, in a popular wallet like Electrum here, that is relatively straightforward. There's been some real leaps in the sort of user experience here, and it's relatively straightforward to go ahead and open a channel. We can, in some cases, even both parties can commit funds to the channel, although that's a bit more of an experimental capability. In most cases, it's one side commits funds or the other side commits funds. And to open the channel, we provide their node ID. We say, great, here's the other node that I'm trying to connect with. We're going to do a handshake. We're going to say, great, we want to open a channel. We'll publish that transaction on the blockchain, and boom, we have a channel with, in this case, 1.5 Bitcoin worth of capacity. That's a pretty hefty channel. That's a lot of money that we can move between us. So, if I want to actually execute a payment, again, how is this different than what we're used to on the Bitcoin network? Well, on the Bitcoin network, we talk in terms of addresses. We talk in terms of fixed addresses where I make a transaction. That transaction is published on the blockchain, and my funds, my chunks of Bitcoin, they arrive at a particular point that everyone can see, at address 1ABC. On Lightning, it's designed around payments. It's not designed to be a decentralized ledger, a public ledger for everyone to see. So instead of addresses, we have invoices. And invoices, they can't be reused. It's not like an address. It's not a fixed point. It's a one-time invoice. And actually, if I don't use it, they expire. They expire after a period of time. So invoices are more like a route of how to send the Bitcoin to me, what Bitcoin are you trying to send. And specifically, though, when the Bitcoin actually flows, when the sender sends to an invoice, the payments channels, if it's a direct invoice, if I'm paying directly to Joe and we have a payment channel between us, our payment channel balance updates and we're good to go. We've now updated our balance. However,
in many cases, I might not have a direct connection with my intended recipient. I want to send funds to someone I've never met over the internet. I don't open a channel with them directly. Instead, if they're also connected to the Lightning Network, if they have an open channel with another node, perhaps I can find a way to route my payment to them without opening a channel directly. And that's where the Lightning Network starts to become really useful. Because if I had to open a payment channel with every single person that I interacted with, what's the point of Lightning Network, right? I could just do those transactions on the Bitcoin network. Every Lightning channel has to be opened on the Bitcoin blockchain. Therefore, in order to be useful, the Lightning Network needs to route funds. And that's where things get a little bit more complicated. Here, we've got our good friends, Alice and Bob. And Alice and Bob, they don't have a direct channel between them. However, they're both connected through a couple different connections to the Lightning Network. And what Bob can do, if Bob says, I would like to receive X amount of millibitcoin, and Bob sends an invoice over to Alice, Alice can use that invoice to essentially route a payment across the Lightning Network, across various channels, and have that payment arrive at Bob. Now the path from A to B, that can be a little bit tricky to find. This is a sort of unresolved computer science problem, but roughly, Alice's Lightning node, it's going to try and find various routes to Bob until it is successful. And the way this payment routing works is each hop along the way, it's just each channel is updating their balance saying, okay, funds flew in, I'm going to send some funds out, and no one can intercept that payment. One of these intermediary nodes, halfway through the chain there from Alice to Bob, they can't say, oh, I've received the funds, I'm just going to stop and take the funds for myself. That would be, obviously an ineffective payment rail. Instead, they're only able to either process the entire transaction all the way to Bob or not process it at all. So there's really no risk here for Alice transferring those funds along a route. Instead, it's either the payment completes or it doesn't. The route is just how it happens to get to Bob. Now, naturally, these routing nodes along the way, they charge some fees. So that's where we have the slight fees on the Lightning Network. But today, at least, those fees are pretty minuscule. And for the most part, they have been minuscule even in times of higher demand on the Lightning Network. So we'll talk a little bit more about routing when we get into the topic of transaction monitoring, and Joe's going to walk us through that in just a moment here. But lastly, one big question here is, okay, we have this decentralized network, we have these routes where we can potentially route across this network, route across these various links to find a way to Bob, but practically, it's a whole lot easier to go through big centralized hubs. And this is one of the centralizing trends that we see on the Lightning Network. We have public node providers, often services, where they open lots and lots of channels with lots and lots of entities. You can kind of think about this the same way that airlines have hubs where lots and lots of flights connect through, say, Atlanta Airport. It's the same on the Lightning Network. It's a lot easier
Don't do it in
route.
summer. It's terrible.
Yeah.
Always a storm in Atlanta.
Don't fly through Atlanta, courtesy of Joe. But here you have an easier connection point. It's a lot more efficient to route through this centralized hub, but again, where there's maybe a trade-off here in terms of decentralization. If everyone uses these centralized hubs, maybe they will have the ability to effectively block transactions on the network since they are the only route from point A to point B. This is something we'll also see a little bit more when we get into transaction monitoring, but it's worth being aware of that we always have these ideals of decentralization, but we have these practical factors that maybe favor some centralizing forces, and this would be one of them. It's often easier to route through these well-known, public, very well-connected nodes that sort of serve as hubs on the Lightning Network. But with that, I will go ahead and pass it over to Joe to talk us very briefly through Lightning Network adoption and then jump into transaction monitoring. Thanks, Joe. Oh.
There we go. All right, good. So we use this word service all the time, and just kind of throw it around. It describes basically large centralized entities that are doing something specific in the cryptocurrency ecosystem. But what service are exchanges providing? Like at base, what do exchanges do? Takers? Yeah. They are providing conversion and they're providing liquidity. So in this world where, again, we're ideally conducting these transactions in a decentralized fashion, well, who has liquidity to provide? Technically speaking, when you open up this channel, you are committing your cryptocurrency for an extended period of time, and who can afford to keep 1.5 Bitcoin locked up in a channel and then, in perpetuity as this financial relationship that you've established with another entity or person goes on. We establish these channels because there's going to be an ongoing financial connection, like, me going up to the bar several times and just wanting to get drinks quickly without paying for them individually each time. Well, exchanges, right? Exchanges maintain hot wallets, and the whole purpose of those hot wallets is to facilitate rapid transactions. And they are the ones that are capable of committing that much cryptocurrency at a single time and just having it be an outstanding balance. So they are some natural points of conversion, as Adam said, hubs like Atlanta. Unfortunate for you if you do get routed through there, but moving past Atlanta, they're actually playing an outsized role in the function of this network, in getting this network to work. So there is no complete set of Lightning Network data. All of the graphs you're about to see are really based on estimates. There is the technical ability to very easily run a Lightning channel and run a Lightning node on the Tor browser, through Tor browser. So those are anonymous and therefore difficult to get any estimates on. But then there are also public nodes, and those have the bigger role somewhat naturally because if we're thinking about large centralized institutions, they're going to publish a public node. They want people to know about it and therefore connect to it. And if you are going to send from a private node being run through Tor browser to someone else, the easiest path is often to connect to a public node. So that dynamic means that these are estimates, but let's get into some things that we can glean from the data. First thing is capacity. So this is, as Adam mentioned, something that is measurable. We can tell when a Lightning channel is opened, and therefore we can tell how much cryptocurrency is locked up in the network. And what you see over time is that we have almost 4,000 Bitcoin as of, I guess, last week when I made this graph, locked up in the Lightning network. That's how much capacity this payments network has to process transactions between, point A and point B. USD value, price has somewhat plummeted relatively recently, so this is how much money, and this is not, you can't currently send $200 million through the Lightning Network. It's just that is how much is in it. You can really only send something like much smaller than that, because again, each channel has to have a certain capacity to pass transactions through it. And then finally, the number of channels. One thing I didn't put in here, but which is actually a very good metric, is when we look at channel closures. Many of us are used to analyzing Bitcoin transactions as that one input, two output transaction where there is a payment and then there's change. But where we see evidence that there is significant usage in the Lightning Network is when there are two output channel closures. So when Adam and I are deciding, I paid for this, you paid for that, we settle out our balances. If we see the ultimate Bitcoin go to two addresses instead of one, what that indicates is that this Lightning channel was actually used between two people and not just aspirationally opened by one person who's an enthusiast about Lightning Network, right? So there is a lot of different technical information, and we can therefore monitor transactions somewhat differently. But just the thing to keep in mind is that this is intended as a payment solution. So we are expecting retail level payments being made through this network. We're expecting small amounts. You can actually send, I think, far smaller amounts than a single Satoshi through the Lightning Network. So we might continue to see increased adoption as the price of cryptocurrency rises, as the market recovers from this slump and Bitcoin just becomes very, very valuable in a USD equivalent. So Lightning Network and transaction monitoring, first, why might cryptocurrency businesses want to do that? Well, from a practicality standpoint, if you don't want to be connected to the Lightning Network all the time, if you don't want to constantly be running a node and have your wallet connected to the greater system, which is a security risk, well, you're probably going to use an exchange account to facilitate one of these Lightning Network retail level payments. If we're thinking about the concept of an ongoing financial relationship, and this is always funny, but I end up saying this quite a bit, but gambling is a perfect Lightning Network use case, right? We are opening up this relationship with the gambling service. We expect to win sometimes, we expect to lose sometimes, but where someone is using cryptocurrency to actually gamble, we expect that balance to change and go back and forth, and we expect them to want to see their actual balance all the time, have it update very quickly. It's a habit. We call it a habit for a reason. So gambling, really good use case. Peer-to-peer payments as well. A lot of the reasons why exchanges exist at all, they might especially want to participate in the Lightning Network. So what are the things that we can see? Now, one thing that is odd to me, used to working, again, with very descriptive 64-character transaction hashes in the Bitcoin network, is that we do have this unique payment hash, but it is far more opaque and less descriptive than a Bitcoin transaction hash. But we do have the payment hash. The thing that is actually quite useful and interesting is this node public key the funds are being sent to. So in order to be a node and open up a Lightning Network channel, you must publicize your node public key. And baked into that node public key, if you are, again, a public channel and wanting people to use it, is an IP address. So again, thinking on this practicality in payments versus decentralization scale, the IP address is a very unusual piece of information in the cryptocurrency ecosystem because it physically grounds where a channel is and therefore where a service is. And this is going to be important when it comes to transaction monitoring and mitigating risk. We then have a timestamp that's fairly standard, normal, and then the asset is always going to be Bitcoin. So just a reminder, this is not like a new cryptocurrency. It's not like a token being built on the Ethereum network. It is, in fact, a second layer solution. We are moving around simply smaller chunks of Bitcoin in a faster way through the Lightning Network. So that last piece of information is just going to be different. It will say BTC Lightning. You are still moving BTC as value, just through a different path. So what's different here is you see a service, bit refill, exchange, and that's in Reactor, right? But services that also are running Lightning Network nodes, they, again, want people to use them and know about them, and so they will name themselves in the Lightning Network after the main service name. So this is just really a linguistic source of attribution within the Lightning Network. It will play into the exposure that we end up getting in KYT. So first thing is just similar names, very simple. Probably the most simple part of this training, right? So here is their node. We have bit refill routing, and I just included this screenshot of Reactor just to show you this is where we get that same information. Some other things to note here, they have their business description, right? That is what they do, and that tailors, they also list their Twitter and their website. So this is how we figure out the nature of a service and do some attribution work within the Lightning Network itself. Another thing here is you cannot perceive the public node key that funds originate at. So we are only ever going to be seeing, from the perspective of a service that has adopted KYT and integrated with it, we're only ever going to see sending exposure or withdrawals coming out of that service in the KYT interface. So here I put in a whole bunch of received transactions, but it's not showing up in the exposure wheel because we're never really going to be able to harvest that kind of data. So we can see the value moving, but not the origin. Another thing to note here is, and we'll talk about this more in a sec, but just note, there is no concept of indirect exposure in Lightning. It is simply taking whatever path your wallet software can find and moving funds from point A to B, and there is no relevance to the intermediaries that it travels through. And here is that slide, right? So we are just sending funds from A to B, and it's going through whatever path it can find, not necessarily the cheapest or shortest path, but just the first path that it can find. And again, the thing that a user is going to request when they request a withdrawal through the Lightning Network from a service is they're just going to specify the node public key that it goes to. So no indirect exposure. The intermediaries are not relevant except to the person who is probably getting fees passed on to them. It's how expensive this transaction is. So everything direct, and then finally we have this IP address concept. Again, very unusual. The only other thing that I can really think of off the top of my head is cryptocurrency kiosks, which physically ground Bitcoin transactions or cryptocurrency transactions in a specific place, right? So when you are going up to a physical machine converting cash to cryptocurrency, that service, that ATM, knows which machine was used and where that machine is. So valuable information in that context, and then in this one as well, except that, you know, a physical location is far more immutable than an IP address. We can still obfuscate our IP address using a VPN or hosting service, but nonetheless, we can still get some valuable information about where services are in this way, and that's particularly relevant to the risk category high-risk jurisdiction, right? If we detect and screen this IP address in you know, places that are incorporated into that category, suddenly the transaction is purple. Okay, and then finally, let's talk about alerts. There is, as you can tell, like limited attribution information in this network, and we can't use the same heuristics that we would normally use to build a cluster on a different, you know, on the normal Bitcoin blockchain. Instead, what we can do, and I'm about to say behavioral alerts, I'm a big stan, that's what the Zoomers say, on behavioral alerts, but these are just really concepts that have always existed in fiat transaction monitoring that we can use to de-risk Lightning. And the important thing to establish first is Lightning is intended for retail payments. So that is our base level. You know, when you pay a fee on the Bitcoin network, even if it's $65, you know, it's $65 whether I'm sending Adam 10,000 Bitcoin or 0.1 Bitcoin. It's the same fee. It has no relationship to the amount being transferred, whereas Lightning Network transactions, they scale. So the more that you are sending through the Lightning Network, the higher fee you're paying. So at a certain point, it would be very unusual and expensive to send funds through the Lightning Network, you know, that exceed a certain amount. You're just paying a very high fee there, and that's an unusual behavior. And suddenly that would kick a otherwise normal-looking transaction into a realm of, well, why are you doing this? Is it in the name of obfuscation? So you can create these value-based behavioral alerts, and just sort of walking through some of the you know, categories here. I've named the rules. I expect that capability to be incorporated into the interface soon, but we have rules that target high-frequency trading. Now, again, we expect this to be an ongoing financial relationship, not just like instanced transactions. And so we'd probably want to raise the threshold before we're actually looking at a user, because we expect users to be transacting frequently through this. And then the other thing, here at the bottom, I have the source of funds rules. Would probably lower these a little bit for the Lightning Network, because again, it's expensive and you know, ultimately not efficient to send this much in cryptocurrency through Lightning. And then in the middle here, you know, just some basic structuring or layering typology. So structuring, it's an offense in the United States. It's not an offense elsewhere because very few jurisdictions have a currency transaction report threshold, right? So if I take out $10,000 in cash, that is an automatic report that is filed with FinCEN and with probably whatever state jurisdiction I'm conducting that transaction in. Doesn't exist internationally, except in a few countries like Brazil and Austria, but I think it's around 5 to 10. So structuring, only really a relevant offense in the United States, and you can configure rules to look for that behavior. Multiple transactions within a short time frame between $8,000 and $11,000. When you're dealing with cryptocurrency, which is quite volatile, you are liable to make mistakes and structure incorrectly, right? So people that are avoiding that $10,000 threshold, you must prove knowledge of the threshold in order to create a rule like this. And actually, it's an independent money laundering offense. So something good to look for, even if people are doing it correctly, because it means they have something to hide. And then finally, just like a generic layering rule. So just multiple transactions in a very short time period, not sure exactly why you're doing it, but I would probably raise the threshold on the number of transactions here because, again, we expect high frequency with this particular use case, intended for retail level payments that are precise and instant. So that is simply what it ends up looking like in the interface. And you can incorporate Lightning Network transactions through the KYT API and create a specialized set of rules that are quite separate from normal value transfer rules, because we want to treat Lightning differently based on what it is intended for as a solution within the Bitcoin ecosystem. Any questions, everyone?
Sorry, Joseph Bitbuy. Is the assumption that you have a Lightning node that you're running and then you're submitting all those transactions, or can you also monitor the Lightning node for clients that are exiting or entering?
Yeah, so I mean, if you're going to transact as an individual with your own wallet software, you need to have the node running, right? But I feel like there is a little bit of technological pressure that if you want to use this, you're probably likely to conduct this transaction through a service. And services will have greater security, and they will have a node running all the time.
Yeah, so the reason why I was asking is I know there's Bitrefill, there's Exodus, there's a bunch of them that are running it on behalf of the users. There's no way to monitor that with this tool, right?
We know the node exists, but really this is from the angle of you have sent us your data, yeah.
Is the payments channel multi-directional, as in, like, in a bar tab, you're only paying the bar? But what I'm curious about is, could the channel be used to go in both directions, where I'm paying my counterparty and my counterparty's paying me?
Yeah, definitely. And that's a key aspect of the Lightning Network. So that's where, the bar tab, in our analogy, it's an imperfect analogy, but we can, give you a get one free drink, and then the payment goes back.
Yeah, I want a bar with a rewards program,
Basically, that's what we're looking for here.
Okay.
And that's also key in the routing aspect, because maybe, you are not paying your counterparty all the time, but someone else is able to route payments through, and you can adjust the balance there in a direction maybe you wouldn't adjust it normally, because a payment is being routed through your node. So that's where, a bi-directional channel is sort of fundamental to the Lightning Network.
Got it. Thanks. Two questions.
So I saw like your earlier slides. You guys have around like 200K USD value in the network right now. Is that correct?
I think it's a higher number than that.
Okay.
Yeah, so that would be million.
Yeah, sorry. Yeah, millions. So I guess my question is there a maximum amount of capacity?
I guess it would be determined by the largest channel, right? Which I don't know off the top of my head, and seems like something that's liable to change. But if you're using this the way it's intended to be used, then I kind of doubt that you would hit maximum capacity, because again, exchanges, they're facilitating a lot of channels and a lot of connections, and so they're committing like well upwards of 50 Bitcoin to, opening one of these.
Although one thing to remember with this graph as well is, just because there's $150 million worth of Bitcoin locked up in the Lightning Network doesn't mean that I can send $150 million worth of Bitcoin to Bob. That's the total amount of Bitcoin locked there. Channel capacity, route capacity, is going to be much, much lower, and that's where we get into that sort of traveling salesman problem of how do I figure out the best route to the other side of the Lightning Network, and how much capacity exists on that route.
Yeah, so it sounds like the answer is that there's no cap. So for example, let's say there's $5 billion of interest in the future. That's not a problem, as long as there's proper nodes.
Yeah, I mean, theoretically, you could lock up the entire Bitcoin supply in the Bitcoin Lightning Network, but that's probably not what we're going to see.
Thank you.
Actually, one sec here.
Can you talk to some of the monitoring tools out there to identify channels such as 1M and things like that?
Yeah, I mean, it's really like public explorers that aggregate them. And again, I was going to a lot of different places to try and get a sense of the data that's out there. But 1ML was the primary one that I used for like the attribution. As far as the ins and outs of it, when we first implemented this capability, we had like quite a sprint to figure out, who was who, and then particularly where they already were a service within the Reactor and KYT interface, really targeting those and because that's where we can easily attribute. We've already determined the nature, but it's really harvesting data from 1ML and other, equivalent sites.
Although, yeah, one key caveat to the data in our graphs here and also in public explorers like 1ML is that that's only the publicly declared channels. I can have a private channel that's not known to anyone, and again, this is not a public network where every transaction is recorded. My private channel, if it's not declared, we have no idea it exists.
Yeah, and one other concept is you can follow the exposure when a channel is opened and when a channel is closed. So, for instance, if we saw a ton of darknet market funds flowing into a Lightning Network channel, that would help us attribute it as a darknet market.
And sorry, I think we are technically out of time. I don't want to run over time, but we can certainly, I know there's a few more questions. Joe and I will be over here to have a discussion. But thanks so much, everyone, for the attention. And I hope this session has been useful.
Thanks, everyone.